Welcome back to part 2 of putting this ECS system to work in Unity. Okay, so hands up who tried 1,000 by 1,000 cubes in their cube spawner. Well, I have, and I'm sure some of you did too, just to see what would happen. I'm currently trying to drive the Warthog across the surface, and you're seeing the real-time lag that's going on in my system. It's just not handling it. What you have to remember is there's now 1 million cubes sitting in the hierarchy. Each of those cubes is a game object, which means it has a transform, a cube mesh filter, a mesh renderer, a box collider, and whatever else you might have put on your game object. Okay, and this is a simple game object, it's just a cube, and it's really struggling. So while it is struggling, let's have a look at the performance. So let's go up to, we want window, if we can possibly do this while Unity is struggling. And we're going to go down to analysis, pull up our profiler window. Now, when we get that, we're looking for, remember, the memory. Now, this is probably going to be just lagging so much, it'll be very difficult to get to it. Here it is, oh, just up there. Bit. There it is. Okay, so with that, let's have a look over in mono at what we've got. So it's currently sitting at 273.5 on my computer. So take a note of what yours is telling you so that you can compare it with what we're about to create. Alright, so let's close that down, because this is extremely painful, and stop playing. So when you finally get out of that, what I want you to do is to make sure that you've already saved this scene, but then we're going to save it as, and let's call it E Perlin cube. So this will be our ECS version. Save that there. Now we need all of the bits that we had before, so we still need a camera, we still need our spawner, our spawn warthog, but with the spawner in this new scene, just grab hold of that and we're going to delete the spawn cubes script because we're going to write our own special version of that. So just remove the component off of there. Right, so now we're ready to start ECS coding. In the hierarchy, we're going to create another cube. So 3D object cube. Now this cube is currently a game object. And as we saw just before, a game object is a very heavy thing to have in memory. We're going to convert it into what Unity is calling an entity. So an entity is something that you will not see appear in the hierarchy, but yet you can have millions of them in your game scene. And instead of being really heavy with all of these components, they share their components. So they all point to the same components. And that means that the whole thing's not so heavy. So it's kind of like the scriptable objects that we looked at before, but taking that one step further, not just removing data, but removing this functionality of the components as well and sharing that among all of the entities. Okay, so what we're going to do with this cube is make it into an entity. Now, in the current version of ECS, you have to write a bit more code. Okay, it is a bit of a laborious process what you're going to have to go through to get this to work, but it does perform a lot better, and I'm sure as Unity make more and more iterations of this, the whole thing's going to get way more streamlined, because when I first had a look at the first iteration of this, it was like really difficult to understand because you couldn't even see your game objects, and yet you had to make these entities without having sort of access to them like you do right now, which is much better. So this is a massive big improvement I've found. Anyway, enough about that. Let's click on our cube and we're going to make it into an entity. go to component. Now we're looking for convert to entity. You can see I've already typed ent in there in the search. So click on convert to entity, and what that's going to do is at runtime, or I guess when the cube is sort of created, it will become an entity. Now that will kind of strip it of components and allow it to share different components and that. Now what we're going to do is write code that then adds components onto it. Right, so let's go down into our assets. Let me come back out into here. We're going to create some code called Perlin position proxy. So create C# file, and let's call it Perlin position proxy. And I guess it's the proxy because it's going to become the component on the entity, but at the moment it's not. It's on a game object. All right, so this will become clearer as we go along. First of all, we kind of need to get rid of all of the usual engine libraries and things that we've got from before. So we want using system, we want using unity.entities, we want using unity.mathematics, and we want using Unity Engine. Okay, so with that there, this Perlin proxy is a mono behavior, which is going to allow us to put it onto that cube, but it's also going to inherit from a few other things. So it's going to be an I convert game object to entity, and just in front of that, we're going to require this to have a conversion. Requires entity conversion there. Okay, so now we've got this. Now I know that we're getting an error at the moment with this I convert game object to entity. That's because we are missing a very crucial method inside of here, which we're about to write. So let's get rid of what usually comes in a mono behavior and put this one in instead. So it's a method called convert, and it's going to be a public void convert, and it will have entity manager, and the entity manager is a kind of pool of all of these entities. Manager, and then we want in the third position in here a game object conversion system. I can't spell today. Conversion system, we will call that. And then inside of here, we're going to create some data. var data equals new Perlin position, something we are yet to write. So it's not going to like that initially, and try and call it something else. And then on the next line, we're going to go the manager dot add component data to the entity of data. Right, so what's happening here is that we are essentially creating a new component, which is there, and then adding that component onto our entity, which is going to be our cube. And so this code is doing that for us. The reason being is that later on inside of the system, the only way to really find entities is by the components that are attached to them. So we're kind of creating this kind of empty component because we're not doing a lot with this current little system that we're writing called Perlin position. Right, so now that we've got that, let's save it, and we're just going to go back into Unity and we'll create that Perlin position code so we can get rid of that error. So create C#, let's call it Perlin position. Open that up. Now it's not a mono behavior. In fact, it's pretty much almost nothing. So let's get rid of the contents of the class. Let's just have system at the top, and then we want using unity.entities. Make sure it's unity.entities, not that. And then we're not going to be creating a class, but a structure. Now, if you're brought up on C or C++, we'll be very familiar with structures, and they are very lightweight things that hold data and some methods. It's not going to be a mono behavior because we're actually creating a component that will stick onto our entity. So this is going to be an I component data like that. Okay, now just ignore my current Visual Studio, which doesn't like all of this because there's nothing wrong with it. It just does this sometimes. But anyway, we now have a Perlin position, system, entities, structure, save it. Okay, now if we go back into Perlin proxy, it's going to update itself so that the Perlin position is not going to be an error anymore. All right, and there we have it. Okay, so we have gotten rid of our errors. We have our Perlin proxy, position proxy, and our Perlin position. So let's go back to Unity. You want to grab hold of the cube that you've created in the hierarchy, and you want to add the Perlin position proxy script to it. So drag and drop that on. Then you can make a prefab out of this cube. So first of all, just rename the cube, and I'll call it E cube, so we know it's our ECS cube. Then drag and drop that down into your assets, and now you have something that's ready to become an entity. Go back into the hierarchy. Now the spawner itself, we're going to also make that into a entity. So add component, convert to entity on that. Now we're also going to make a proxy script for it as well, which is going to, I guess, essentially set up the system so that it can create all of those cube entities for us. So it's the other way of doing what we did previously with the spawn cube code. Right, so let's right click, create C# script. We will call this our spawn proxy. I'm going to open that up. And then inside of there, what we want to do is replace, what do we do? Get rid of those ones. Okay, libraries first. So using system.collections.generic, and then using unity.entities. Okay, now we are going to inherit from mono behavior, but we're also going to put in a few other things which will allow us to turn this whole thing into an entity spawning system. Okay, so I declare referenced prefabs is the first one, and then the second one is going to be I convert game object to entity, which is what we had going on with our cube, or our E cube. Now, of course, it doesn't like them currently because they need methods associated with them. Let's get rid of start and update. Don't need those, but we do need to public game object our prefab. So this is our cube. Let's call it cube. And then we want a public int for our rows and a public int for our columns like we had previously. Now I declare reference prefabs needs its own method. Okay, so that's public void declare referenced prefabs, which is going to be a list of game objects. Then in there we go game objects dot add our prefab, which is our cube. Okay, so that takes care of declaring and creating our prefabs. And then down in here, public void, we need to put in another convert, exactly like we had before. And you know what? I'm going to cheat. I'm going to go back to the Perlin proxy and just copy that so I don't have to type it all out again. Put it in there. Make sure I've got a closing bracket. Then inside of the convert, we're going to declare some spawner data. So spawn data equals new spawner. And again, we haven't declared the spawner class, but we will. It's essentially going to act as an interface between the spawner, which is a game object, and the spawner, which is going to become an entity, so that we can pass these values here through from the game object into the ECS system, which means we need a holder in here for each one. Now, inside of spawner, we're going to have to declare a few things. Again, we haven't done that, but we'll get around to it. So let's create one called, actually we won't call it cube, we'll call it prefab, so it's a little bit more generic. Equals conversion system dot get primary entity from our cube. And we want rows, or let's put e rows equals rows, and e cols equals cols. Now, I've accidentally put a semicolon on there. Notice that we're not semicolon, is that a word? Put things in here. This is putting data and declaring a instance of a structure. Okay, so it's a little bit different to typing out lines of code with semicolons on the end. So make sure when you're doing this, you do not put semicolons. It's commas between these values. However, there is a semicolon that you need to put right at the end. So make sure you've got that in there. Then we want to add the component data that we've just created to our spawner entity that we've also just created. Like that. Now, what this means is we need to go back and declare a new structure called spawner so that we can pass this information through to it. Right, so save that and let's go back to Unity. Right click, create, C#. This will be called spawner. Open that up and get rid of the contents of spawner, turn it into a struct. It's not mono behavior, it's going to be an I component data, and it will be using unity.entities like that. Then inside of here we declare those things that we had in the spawn proxy, which is prefab, erows, and ecols. So back in here we want a public entity, which we've called prefab. We want a public int called erows, and we want a public int for ecols, like that, so that the entity for the spawner gets created and it now has a spawner component on it and is passed through that information from the inspector. Okay, great. Save that, and now all of our little errors and things that we've had before should just disappear, as you could see going on down here. When we come back in the next lecture, we'll start writing the code that actually spawns our cubed landscape. Thanks for watching. Please support the development of more superb online learning content by subscribing, and as always, visit holistic3d.com to learn more about awesome games development books and tutorials.